Welcome to The Explainer. Today, we are diving into something that's, well, it's a huge deal. We're talking about agentic AI, a frontier in technology so powerful, it's looking like it's going to transform everything from how we discover new medicines to how we even interact with knowledge itself.
Okay, so to really wrap our heads around this, let's kick things off with a pretty wild question. What if an AI could do more than just answer your questions? I mean, what if it could run the entire scientific process all on its own?
And that right there is the heart of agentic AI. These are not your average chatbots. We're talking about systems designed to take a big, high-level goal, and then they can actually reason, plan out a series of steps, and then go use tools like software or databases to get the job done. They are quite literally agents of action. To make this feel a little less abstract, let's look at a mind-blowing example coming out of Stanford University. They've built this thing they call the virtual lab, and it's basically a platform where teams of AI agents get together and collaborate just like human scientists would. So here's how this crazy virtual lab actually works. A human researcher comes in with a high-level goal. Then you get this professor AI, the lead agent, who goes and recruits a whole team of specialized AI students. Maybe one's an expert in immunology, another in machine learning. You get the picture. These agents then have group meetings, they debate ideas, and they hammer out a concrete research plan, which is then handed off to human scientists for the real-world lab experiments. And this is where it gets really, really interesting. This is where we see the AI's creativity just pop. So they were tasked with designing these things called molecular binders. You can think of them like tiny, super-specific keys designed to lock onto a virus. A human team, they probably would have gone with standard antibodies, right? The tried and true method. But the AI team, they came up with a fairly unorthodox suggestion: nanobodies. These are way smaller, simpler structures originally found in animals like camels that just happen to be a much, much better solution for this specific problem. And listen, this wasn't just some theoretical idea. The agents sifted through a gigantic design space and narrowed it down to just 92 of the most promising nanobody candidates. And those 92 were then actually created and tested by humans in a real lab, leading to potential new treatments. Amazing, right?
So, okay, agents can speed up new discoveries. But what about all the knowledge we've already got locked away in research papers? Well, it turns out agentic AI is also about to completely change how we interact with all that existing knowledge.
For literally decades, research has been shared through static PDFs. You read it, and that's it. But a project called Paper to Agent just flips that whole idea on its head. It turns every single research paper into its own interactive AI agent. So instead of just reading a paper, you can now collaborate with it. You can ask it to analyze your own data using its methods, and you can even have these paper agents collaborate directly with each other, totally skipping the human bottleneck of sending emails back and forth. And this chart, man, it just perfectly shows you how much more efficient this is. Look at this. Giving the task directly to a super powerful model like Claude, let's call that 100% of the time. But using the paper to agent, it took less than a third of that time. We're talking faster, cheaper, and way more reliable. So these applications are absolutely incredible. But to build them, you need a completely different philosophy for how we actually train AI models in the first place. And here is the absolute crucial point. It's this shift in the training goal. You see, traditional models like our chatbots are trained to align with what humans prefer. The big question is always, does this response sound good to a person? But for an agentic model, the goal is totally different. It's about aligning with feedback from the environment. The question is simpler and so much more powerful. Did the task actually succeed? Yes or no? To train for that kind of success, you really need 3 key ingredients for your data. First, you need environments. These are the digital sandboxes where the agent is going to operate. Second, you need tools, the specific commands or APIs the agent can actually use to take action. And third, you need verifiers, automated checks that give that black and white feedback on whether the task was completed successfully or not. So we have a new way to build these agents, which is great. But this brings up a huge, thorny question. How do we even know if they're actually getting smarter? I mean, how do we measure progress? Well, here's the catch. According to researchers, we have a massive measurement problem. Think about classic AI benchmarks like ImageNet for pictures that had over 100,000 examples. But for these super complex agent tasks, a major one like Human Eval for coding has, wait for it, just 164 examples. Can you believe that? The tasks are getting way harder, but our tests are getting way, way smaller.
And that tiny size has a huge consequence. As Sita Wang from Meta points out, when a new model claims it has a small improvement on these tiny benchmarks, many of the improvements are certainly not significant. Statistically speaking, it might just be random noise. We could be fooling ourselves into thinking we're making progress when we're really just spinning our wheels.
And that's where we're going to leave it, with this really big, important question. Agentic AI is without a doubt this incredible new frontier, but its real progress, well, that all hinges on solving this fundamental challenge. I mean, how can we truly build the future if we can't even reliably measure where we are right now? Thanks for joining us on The Explainer.